Let's take a quick look at cosecant and secant. Remember that cosecant is 1 over the sine of x, and secant is 1 over the cosine of x. So they mirror sine and cosine. Secant, notice if I were to draw the sine curve in here, sine starts here at 0, 0 and goes up. Okay, but when sine is at 0, that's, remember we hit an asymptote there because cosecant is 1 over sine, so anytime sine is 0, we get undefined, and that creates an asymptote. So everywhere our sine function came back to 0, we're going to get an asymptote. Okay? And the closer it gets to 0, the bigger the number gets, because if you think about it, if your sine was 0.0001, if you do 1 divided by that, you get a really big number. Okay, so that's what's happening. One way that I remember them is if I can just remember what sine and cosine look like, okay, I know that it's 1 over that. So everywhere there is a hump on my sine function, I know there's a curve for my cosecant. And again, everywhere sine hits 0, you put in an asymptote. Okay, so notice here's a sine hump. We want to go the opposite direction forever. Okay, here is a sine hump. We want to go open up the opposite direction. Okay, this would be a sine hump here for my sine function. Go the opposite direction. So if you can remember what sine and cosine look like, you can sketch a graph for cosecant and also for secant. Now secant was 1 over cosine. So again, every time we get to a place where cosine was 0, we're going to have an asymptote. Okay, so that's why pi over 2 has an asymptote for secant, because cosine is 0 at pi over 2 and at 3 pi over 2. Now if we were to draw a cosine function, remember at 0 here it starts up at 1, comes down through 0 here, hits -1 for pi, comes back to 0, up to 1, back to 0. Just like with our secant, or with our cosecant and our sine, notice the secant function, everywhere there's a hump on the cosine, the secant's going the opposite direction. Okay, and that all has to do with reciprocals of fractions. The smaller the number on the bottom of a fraction gets, the bigger your answer will be. Okay, let's do some matching with secant and cosecant. Notice, I want you to notice none of these have been shifted right or left. Okay, so that's important. So let's take a look. Y equals the secant of x plus 2. Okay, so what should secant look like? Let's remind ourselves. Well, secant is 1 over cosine. So since cosine looked like this, we want secant to have asymptotes here and here, and have a hump right here at 0, okay, and have one here at pi, and then there would be an asymptote here, have another one here. Okay, so let's take a look. We want it to look like that, only the plus 2 on the end does what? It moves the graph up 2. Okay, so we want one where on the x-axis it's symmetric there. So let's take a look. This one is not centered where we want it. This one is not either. Is everyone centered? Here is one, and I'll show you what I'm talking about. See how this one right here at 0, just like we wanted, because cosine starts up here at 0. We want it to go the opposite direction. We have asymptotes in the right places. They're at pi over 2, negative pi over 2, 3 pi over 2. Okay, so this one's looking good, but is it plus 2? Is it moved up? Okay, well remember typically our secant function, okay, had the x-axis here, and it was 1 above that was where it's took place, and 1 below for the lower curves. Okay, so again, what you can do is just take your middle move it up 1, 2, and this should be my middle here. And notice, yep, one above for these, one below, one above, one below, and it's turning in all the right spots. So E is my secant x plus 2. My next one is supposed to be cosecant x plus 2. So what should cosecant look like? Okay, well, it should be with our sine function. So sine, remember, started at 0, hit 1 at pi over 2, back to 0 at pi. Okay, this is what a sine function looks like. Okay, we need to expect asymptotes everywhere the sine function hits 0. Okay, and then we want our curves here to go the opposite direction. So we go up here and down here. And then let's take out my little picture of sine. Okay, so if you can't quite remember, if you can remember what sine and cosine look like, you can always go ahead and sketch what cosecant and secant look like. All right, there we go, but we wanted it moved up 2. Okay, so again, our center's typically here, and then one above we have a hump, one below we have a hump. So we want our center to be moved up 2, but have our curves. See, now this one wouldn't work. See how this curve's centered on the y-axis? That means that one has to be a secant of some kind. Let's take a look at this one. Oh, this one kind of works. Okay, we have our curve right next to the x-axis with an asymptote at 0. Okay, we're on the right track. Has it been shifted up 2? So if we go up 1, 2 from the x-axis, is that kind of a center? It is. Okay, we have a hump 1 above, 1 below, 1 below, 1 above. So my answer for this one is going to be B. These are a little tougher when you're mixing secant and cosecant and have to decide which is which. My next one is that y equals negative secant x. So remember, secant mirrors cosine, is 1 over cosine. So it should be centered on the y-axis. But see this negative? That means it's going to flip it upside down. So that one that's centered on the y-axis, instead of going up, is going to be going down. So let's look for something like that. Does this one work? Nope. See, I don't have a curve centered. My asymptote's at 0, which means this would have to be a cosecant. Would this one work? No. Again, see, I have an asymptote right here at the y-axis, which means this has to be a cosecant. Here we go. Notice I have a curve that's centered right on the y-axis, but instead of going up, it's below and going down. That's because it's secant that's been reflected over the x-axis. So this answer would be A. Finally, y equals cosecant x minus 2. So we want cosecant, but shifted down 2. Our two options that were left are C and D. Okay, if we take a look at C, okay, notice it hasn't been shifted down at all. Each of my curves, this one's one below the x-axis, this is one above, this one's one below. It hasn't been shifted up or down. Okay, what has happened to this one is my cosecant function normally would have a curve up here and down here. So notice what's happened is it's been reflected over the x-axis. So C is the negative cosecant of x. It's cosecant reflected over the x-axis or flipped upside down. And D is, notice if I take my axis, move it down 1, 2 like they wanted, that's my center right there. Okay, everything's in where it was originally, it's just been moved down 2. So D is my cosecant x minus 2. So there's some matching. The more you do it, the better it'll get. I do suggest having in your notes what the graph of sine, cosine, tangent, cotangent, secant, and cosecant look like, so that it makes it easier for you to do transformations and recognize them.